of negative 1. Huh. Can you take the square root of a negative number?
You cannot.
You can't. Something times something, can that give you a negative? Okay, so, sorry. So if I take something squared, can I get a negative? No, right? Because if you took a negative and you square it, negative times a negative gives me a positive. If I took a positive number and I square it, positive times a positive gives me a positive, right? So if I have square root of negative 1, which is not, can't do it, right? Then we call it I.
Is it just a backward J?
Oh, it looks like a backwards J, doesn't it? It's an italicized I. A cursive I. Or I guess you could write it like this, too. I've seen it like
That's
that.
how I use it.
Okay, you can do that. Sure. Your preference. So, this I is called an imaginary number. How fun. Now we are moving on and including imaginary numbers into our repertoire, right? Yes. So, guys, that is the definition. Square root of negative 1 is I. Okay? So let's look at number 1. If I have the square root of negative 9, I'm looking and I go, not possible. Yes, it is. Because this is the same as saying square root of 9 times the square root of negative 1. Do you agree? Right? 9 times negative 1 gives me negative 9. So what did we say square root of negative 1 is? I. What's the square root of 9? 3. So this is 3i. Wow. If I have a negative inside a square root, look at this. Basically, it's an I, right? Because that's square root of negative 1. So let's look at this guy. Square root of negative 121.
11.
Yep, because that's the square root of 121 times the square root of negative 1. 11 what? I. Okay. Now, let's look at example 3. 5 plus the square root of negative 1. Well, 5 is what it is. 5 is my real number, right? What's the square root of negative 81? 9i. Guys, can you combine this?
No.
No, they're not like terms. So, good. This one has a real and an imaginary part to it, right? Okay.
Wait, you can put these eyes to a...
All right, hold on to that thought, okay?
No.
All right, so imaginary numbers. If you have just a plain old I, it's just a plain old I, right? Okay. I squared. I times, what is this?
I to the second.
Okay, all right, so I squared is negative 1, right? Because square root of negative 1 is I, so I squared has to be
Negative
1, right? Okay. I cubed is negative I, because that's I times I times I, so I times negative 1, which gives me negative I. Do you agree?
I guess so.
Right? Well, because if I is I times I equals negative 1, well then I times I, that would be I times negative 1, so negative I, right?
Is it just going to keep on going back and forth?
Well, then think about I to the 4th. What is I to the 4th then?
Negative.
I times I times I times I. What's I times I? Negative 1. And this is negative 1. What's negative 1 times negative 1?
Negative. It's positive 1.
Positive 1. Okay? Oh, so weird. It's a long way. But do you see why this is happening? This is a pattern, guys. If we go to I to the 5th, guess what it's going to be?
Negative I.
It's going to be I. What do you think I to the 6th is going to be? Negative 1. What do you think I to the 7th is going to be?
Negative I.
Negative I. And then 1. Right? So what about I to the 9th? I to the 10th,
-1,
I to the 11th,
-I,
and then I to the 12th?
1.
1.
Okay, so if we keep going, like you guys, I mean, you know the pattern now, right? So if I asked you for like I to the 50th power, well, I mean, I guess you could sit there doing it up until 50, but who really has time for that? Nobody has time for that, right? Here's how you find it if they give you a big exponent, all right? So you could draw this, right? Here's the thing. This is your x-axis, right? That's where your real numbers go. Over here would be a +1, right? Because if this is 0, +1, yeah? Over here is -1, right? Your y-axis, that's your imaginary numbers, okay? So from 0, if you go down to this -I, you go up this +I, yeah? Okay. I mean, there are a bunch of ways to do this. I'm going to show you all of them. So, okay, you can count rotations to see what you get. If you get I, -1, -I, or 1, okay? So what is this? You can count around the rotations, or you can divide the exponent by 4 and use the decimal. All right. If you divide and you use the decimal, let's see, this is 1. This is, what is that? I. -1, -I. Yeah. Okay. I don't use this way. That's why.
My brain doesn't compute.
I'm going to show you the way that I use. I wanted you to see this way. So this, okay, I'll show you. So when you count around the rotations, this is 1, 2, 3, 4. All right. So I mean that's so you could do 1, 2, 3, 4, 5, 6, 7, 8. Okay. But I think that's still a little confusing too. So here's something that you can also do. This is the remainder rule. All right, remainder rule. So if you have a remainder of 1, 2, 3, or 0, okay? All right, and that's the one that I use just because I just remembered it this way. You don't have to use it this way, but the remainder rule goes 1, 2, 3, 0. And your eyes, the pattern, I always try to think of I won. Like I won, right? But the 2 in the middle are negative, right? I mean, because that's my pattern, right? I, -1, negative I, and 1, right? Okay.
I like the graph one better where you just go around it.
Sure, you can count around the rotations. Listen, I'm showing you a variety of things so you guys can choose. The decimal, basically, if you have, you know what, actually, let's go to the examples. This will be easier. Evaluate I to the 15th power. Okay. So here, that 15, you guys have 4 in your pattern, right? I, -1, I, and +1. So what you would do is you would put in, say, like 15 divided by 4 in your calculator. What do you get? Put in 15 divided by 4. What do you get? Huh? 3.75. Okay. So then you see this 0.75? That's this whole thing. So it's -I. Okay. There's that one. Or you could go around the rotations till you get to 15. Or you could do just regular old divide, use a remainder rule. 15 divided by 4 gives me what? Just regular old division like you guys did in like elementary school. 4 times what gives me 15? Or close to 15?
3 for 12.
3. Okay. And then you get 12. You subtract that, right? This is just basic division, right? And then 3, isn't that your remainder? Right? Okay, so then that's what? I1. Remainder is 1, 2, 3, 0. So it's negative I. Okay? Just another way. Alright? It's weird, right? I'm going to use the remainder rule. Remainder 1, 2, 3, 0. I1. 2 in the middle are negative. Okay, let's try 38. 38 divided by 4. It's the closest I can get. 9, right? So remainder of 2, this is negative 1. Okay? And if you use the different way, like you use the decimals, make sure that we get the same thing. Yeah. You counted? Did you get negative 1? Perfect. Perfect. I mean, you guys have a choice of using any of the 3. How about 103? What'd you get? 8. Okay. 2, 3. What is this? 5. So 20. Okay. So remainder of 3. Did you get negative I then? All right.
I've done long division so long.
I know, right? Some of you guys are like, ooh, long division. Don't worry, we'll do that later.
During 8th grade, my algebra teacher
I
got so
know.
mad at me because I would
Guys,
use the
how about
calculator.
I to the 0 power? What is anything to the 0 power?
0.
1.
1.
Uh-oh, is it 0 or 1?
1.
Put in your calculator. Try 5 to the 0 power.
1.
1. Anything to the 0 power is 1. How about I to the 42nd power? 42 divided by
Negative
4.
1.
Huh?
Negative 1.
What is this? 1, 4, 0, 2. Point. Okay, well, you know what? Hold on.
It's
Just 1 minute.
2.
What'd you get? You
It's
got negative
2.
1.
Yeah.
Use a different way. 42 divided by 4. 10.5. 0.5 is negative 1. Right? Okay?
I figured out where 40 was and then I just added 2 to it.
Good. All right. Don't stress. If that doesn't make sense, don't stress. I have a huge surprise at the end.
Is it candy?
All right. Oh, yeah, listen. A plus BI. Here's the number system, including complex numbers. Here's the thing, guys. A is the real part. B, or the number that has the I with it, that is your imaginary, okay? Any number that has the I with it is the imaginary. If you have a real and an imaginary together, this is a complex number. Okay? It's a complex. So, for example, 2 plus 5i, right? Because it has a real part and it has an imaginary part. How about this? A plus 0i. Well, then the I goes away. What's just the A? That's a real number. Right? Example 3. Okay. 0 plus bi. Well, then 0. Bi has an I. Well, then that's the imaginary part. The imaginary number. For example, give me your favorite number.
32.
Okay, 32i. Okay?
What did you just say?
So number classification, you know what? Let's skip this right now. in the interest of time. Okay. Here's what you do. You can take complex numbers and you can do operations with them. All right? You can add them. So basically what it is you're combining like terms. Combine the reals, combine the imaginary. So if you have 4 minus I plus 3i, then there's 4 minus I plus 3 plus 3i. And I usually write it right below the other one,
I
so
got
it's a little
7
bit
plus
easier.
2i.
You can just add straight down. So what is this?
7 plus
7
2i.
plus 2i. Yep. Right?
Wait, do you
Combining like terms.
want it in parentheses?
No, you don't have to put it in parentheses.
Okay.
How about this one then? What is negative 2 plus negative 3? Negative 5. And what is 5i plus a negative 9i?
Negative 4.
Negative 4i. There you go. Pretty good, right?
And now we subtract.
Okay. And then we're going to subtract. Subtracting is basically the same thing, except, you know, you have a parentheses and you have a negative in front. What do you need to do? Good. Distribute the negative. So this is really 4 minus I, right? Minus, actually, I'm not going to put parentheses on that. Just a little bit. There we go. Minus 3 minus 3i, right? And then we can combine like terms. What is 4 minus 3? 1. What's negative I minus 3i? Negative 4i. Do you agree? Okay. You freezing? Pretty cold, yeah. Alright, you know, I'm not going to do B. I'm not going to do that second example. Because, yeah, I told you I have a huge surprise at the end. Okay, let's go to multiplying. Bear with me. You guys are great job. So basically we FOIL or we double distribute everything and then we simplify. Here's the thing, guys. If you have I squared, you cannot leave it as I squared. What was I squared again?
1. Negative 1.
Negative 1. Remember, I squared equals negative 1. That is very, very important. If you want to. So let's try C. I want to do C. Okay? So let's double distribute, right? Because they're multiplying. What's 6 times 6?
36.
What's 6 times negative 3i?
Negative 18i.
Negative 18i. And then let's double distribute this way. What's 3i times 6?
18i.
Positive 18i. And what's 3i times a negative 3i?
Negative 9i to the second.
Negative 9i squared. Right?
So then we get to rewrite this with a negative.
So, combine like terms, what is negative 18i plus 18i?
0.
Yeah. So then now you have 36 minus 9i squared. But, hold on, what did I tell you that not I squared is?
Well, negative 1.
I squared is negative 1. So now this is 36 minus 9 times negative 1. Right? You guys still with me? Okay. What is negative 9 times a negative 1?
9.
Positive 9. So 36 plus a 9 gives me what? 45. So this guy that started out as a complex ended up just being 45. Isn't that cool? Right? I mean, I'm not even making this up. This is really cool.
This would be an awesome April Fool's prank.
So, the reason why I did that one is because 6 plus 3i and 6 minus 3i, those are called complex conjugates. Okay? And basically with complex conjugates, what happens is the sign of the imaginary number part changes. So do you see how it goes from 6 positive 3i and then 6 negative 3i? Yeah? Then you know those are complex conjugates. And when they're multiplied together, the i's, those cancel out. All right? So let's just try a couple of these. What are the complex conjugates of A?
4 minus I.
Yeah, 4 minus I. How about for B?
2I.
Yeah, 2i. Because it's a negative 2i here, so positive 2i, right? What about C?
Negative 3 minus 5I.
Negative 3 minus 5i. Remember, you don't change the sign of the real number. You only change the sign of the imaginary. Okay? And what about the last one? Yeah, 5 plus 3i. Good. All right, you ready? Okay, so here's the thing. I's can all be done on the calculator. Okay? So all of that I just showed you, great. Great if you know it. Great if you do it. If not, just do it on the calculator. Because why would you miss this problem on a test, on a quiz, or on an SOL when your calculator will do it for you? Okay? Focus all those efforts and energy on factoring. Alright? So let me show you. First off, whenever you guys get a calculator, okay, at any point, if it's not your own, go to mode. So go to mode. Everyone, please do this. Make sure. And make sure that your A plus BI is highlighted. Not real, but A plus BI. You want your calculator to, identify imaginary.
What if it's not?
Yeah, then go to it and hit enter so you can highlight it.
So
Okay?
we're going to have to switch in between them?
No, if that's your calculator and you put it on that, it's not going to change. It'll stay on that.
So instead of real.
Yes.
Wait, so then if I were to put in 6 plus 5, would it give me what I need?
Yeah, it would still do the real, but now it'll incorporate imaginary.
Oh, okay.
So I is found on the calculator by going to second decimal. So do that. Oh, okay.
I did it?
So go to second decimal. Do you see I?
Yeah.
Wait,
Okay.
where's the oh,
Decimal. You know where the decimal is?
I see it.
Okay. Now, here's the thing. You can literally put the whole entire operation into the calculator, but you have to use parentheses. You have to put it in exactly the way you see it, okay? And I, with the exponents, all that stuff about the rotations and the remainder rule and all that, you can even do that on the calculator, okay? So let's practice. Let's try number 1. I to the what? Negative second. I, so put in I, second decimal. Oh wait, hold on. No, let's do this. I'm sorry. Go to math. Sorry, I'm not going to do it that way. I'm going to do it this way. Sorry. Math, number. Go to something called I part. Yeah? Now put in I to the little caret right above your division. I is second decimal. And then put in negative 2 and close. What does it say?
Negative 1.
Negative 1? Okay. There you go. That's your answer. And I can show you the long math behind that. All right, but you have this too. So try number 2.
Was this the surprise?
Yeah. This is one heck of a surprise.
No.
Let's try number 2. Put it in exactly the same way is shown there. So I plus 3 in parentheses, and then I minus 3 in parentheses. What do you get?
Negative 10.
Good. And you can double distribute this and you'll still get negative 10. Okay? All right, try number 3. When you're done with that, go to the back. Try all of those. You should be able to get all of those done. For number 3, you should have 5 minus 5i. Yes? Okay. Now go to the back and do those, please.
Right?
Do not get these I problems wrong. Okay? Okay, so practice problems, the answers for 1 through 6. Great job. Look at your homework.